Okay, hello, welcome. This is an Edexcel M1, June 2014, question 1. Okay, so what we've got here is we've essentially got 2 points, and these are kind of ropes, if you want to think of them like that, and they're suspended. Okay, so there's point B where this rope touches the roof. Okay, it's just a wall, whatever you want to call it. I call it a roof, but if you want to call it the floor, looking upside down, think everything is opposite to gravity for some reason. Now you can do that as well, but most people would see that as a roof, so it's up to you if you want to be crazy. Okay, so anyway, the angle, so there's a point B here where it touches the roof, point A where it touches the roof over here. And where they meet, okay, where the ropes meet, if we can think of it like that, is at point C. And at point C there is a weight to spin. Now I'm not told what that weight is, it just says W newtons, W signifying a weight, okay? Just a number. We're told that the tension in the rope B to C is 6 newtons. It says, now find the tension in A to C. Now naturally, what I'd recommend in this situation and go, well, we've got a weight acting down here and we've got one of the tensions, okay? Now we know the vertical, because these are both angled, okay? So it's not at a vertical, it's not at a horizontal. Okay, so therefore each one of these, each part of this tension, okay, so in the rope B to C, yes, that's the angled tension, but there is going to be a vertical component of that tension and the horizontal component of that tension. Same with A to C, there's going to be a vertical and a horizontal component. However, what do we know? Well, we know, again, this is with the principle with all balanced or resolving forces, such as this one, and it's a very common aspect for a question 1. Now, specifically, they're not obviously, granted, they're not all like this. Okay, some of them are slightly, more challenging. Okay, although that's a small minority, I think. Okay, especially for question 1, and it's all about making the horizontal forces balance and the vertical forces balance. Now it looks like there's no horizontal in this, but remember, as I mentioned, there is a horizontal component of this and a horizontal component of this. So if you want to draw it as a force diagram, in other words, I'm just going to draw some dotted lines on here. Okay, so this dotted line represents the horizontal force of this 6 Newton tension. Okay, and similarly there is a horizontal force of the other tension A to C. So as the object is in equilibrium, the forces have to balance. In other words, the horizontal forces have to balance. So this helps us work out what the tension in A to C is. Okay, now there's no point, as I say, we could say, yes, the vertical component of this tension plus the vertical component of this tension, in other words, the tension A to C, we resolve it so it's vertical, and the tension B to C, we put that vertical as well, and add them two components together, that should equal the weight. But we don't know the weight, so we'd have two unknowns. We'd have the unknown, because we don't know what this tension is here, so we can't really resolve it. Okay, well, we can in a sense, but we'll end up with an unknown, so it'll be a known value, obviously, and an unknown value, holding it upwards, and then an unknown value of the weight. Okay, so it's two unknowns, and that we can't do that without another equation. Okay, there's nowhere else we can get another equation from. Yes, we could say this is W equals mg, but still, there's an unknown there. Okay, so as I say, this has a horizontal component, and so does this. Now, this one is going to try and pull it right, and this is going to try and pull it left. Now, as we're told, this is in equilibrium, so they should equal each other. Okay. So again, I'll just put a dotted line this way, saying the horizontal component of the tension in A to C. Now, you may go, how are we going to resolve this? Well, due to alternate angles are equal, or you could just simply just draw the triangle here, okay, and here, say, well, that's right angles, then obviously that's going to be 60 degrees, okay, and obviously you could therefore work out what these two are. Okay, so again, it's very, very simple idea. Okay, so obviously this is going to be 50 degrees and this is going to be 30 degrees. Okay, so now we know what all the angles are. Okay, we can use the idea of, we can create an equation here to be able to work out what this A to C is. Now, just for purpose, I'm going to call this tension in A to C, I'm going to call it X. Okay, just of course I can, and I kind of nothing wrong with that. Okay, so right, so get a better pen. That's probably his worst actually, probably is. Okay, so the first thing I would do is resolve the B to C, okay, so this tension horizontally, okay. So I would say therefore 6 newtons, and we want to work out the horizontal component, so we've got the hypotenuse and we want to work out the adjacent, okay, so it's 6 newtons times the cos of 50 degrees. Okay, now this not going to work that out just yet, but we know that's going to be the same as the force pulling it this way. Okay, so whatever this tension is, we just assume we know it. Okay, so it'll be x newtons times the cos of 30 degrees. Okay, and they are equal. Now, obviously, what you would do therefore is work out what 6 newtons times the cos of 50 is. Okay, and obviously, if you were to do that, I thought I had noted down what that is. So 6 times the cos of 50 gets you 3.856, etc., etc. Now, when you put that answer into your calculator, I would save that, keep it saved so you get an answer, and then I would just click OK, or equals 80 even, and it's stored in your calculator's memory. Okay, basic stuff anyway. So that is going to be equal to xn times cos 30. So if you want to just rearrange to get the xn, now xn just remembers x in newtons, you don't have to really have that n there, just says the units, remember. Okay, so x in newtons is equal to 6n times the cos 50 all over the cos of 30. Okay, so then again it's just putting that in your calculator and getting a value for this x newtons. Remember, this x newtons, as I say, represents the tension A to C. So when you do get an answer for that, okay, oh, excuse me, which should be 4.45 newtons. Okay, that is the value. Now, if you've done it like I have here, you can't just say xn is 4.45 newtons. Well, you can, but you won't get full marks. You need to add on, just explicitly state that that is the tension A to C. So you need to say therefore, okay, so the tension in A to C, okay, is equal to 4.45 newtons. Okay? So hopefully you understand why that is. Now we have to work out the value of the weight here. So now you can kind of just revert to this as a normal diagram now. Okay, so I think I probably will do. Give this a bit of a tidy up actually. By tidy up I mean rub out, obviously. Okay, so we know A to C is 4.45 newtons. So I'm just going to rub off all of these little angle notations, okay? You get it looking relatively how it was before. Okay, so if you're going to pause the video, just have a pause of it now and copy that down. Alright, okay, so just going to, basically I'm just making it so you're not confused at what you're doing with what. Okay, so this is essentially how it looked before I started adding anything to it. Okay, so now we know what A to C is, so we can write it on. Now, again, I would leave this answer saved in your calculator, because obviously we're going to be, I mean, you don't necessarily have to, you can just use the simple 4.45, but it's not going to be as accurate, and, you know, you don't want to be risking anything if you don't have to. Or maybe I'm just being overcautious, but either way, it doesn't matter. So it's 4.45 newtons, okay, and the tension A to C. So we've worked out the horizontal components, and we've said yes, therefore they are both whatever it was. Okay, now we need to resolve the vertical components. Now obviously this only has a vertical component, the weight. It's only acting downwards, it's not acting to the side. Okay, whereas these two, okay, they're angled. So just like we have to work out their horizontal component, we have to work out their vertical component. Now each rope has its own vertical component, and they are going to be likely to be different, okay? But if they're the same, then it's just a coincidence, but they're very unlikely to be different, unlikely to be the same, sorry. And as they are both each holding this weight up. So their vertical component is of B, and the vertical component of A, there's nothing else holding it up apart from these two ropes here, it's going to be equal to the weight. Okay, now we don't know the weight, but we do know both of these points here. Okay, so what I would do is we're going to need to work out the vertical component of each one. Now it doesn't matter which one you do first. I will personally do this one first because you've got the answer saved in your calculator if you have them. Okay, so what you're going to need to do is obviously, well, we've got the hypotenuse here. You can think of that as a right angled triangle. So okay, we've got the hypotenuse and we want the opposite, okay, to the angle. So therefore, the only one we're going to use is sine. So it's to work out the. So you might want to say, underline it somewhere. So the vertical component. So you might want to just write this actually. So the vertical component of the tension AC, or vertical component of AC, plus the vertical component of the tension B to C is equal to the weight. Okay, now it might help, you don't necessarily have to write that, but it just lets you know that you've got to add them together. Okay, and it lets the examiner know you know, that's a load of crap. Okay, so anyway, the vertical component of AC. So as I say, it's about sine. So vertical component A to C. Okay, so it's 4.45 newtons, or the answer you got saved in your calculator, times the sine of 30 degrees. And it should get you an answer of 2.6 pennies. Unbelievably bad. 2.3 newtons, or thereabouts. Again, I would leave that answer saved in your calculator. Now if you're like me and just happen to have a spare calculator, I would advise it at this point. Or maybe I'm just being too anal and this guy is so dull, he's like, copy this answer into your calculator, save it, and he'd probably like to get something more wrong than actually right. So what the hell are you going on about? Maybe you just save this answer. I don't know, you get your answer wrong and you be responsible for loads of people dying because this weight's going to fall on someone's head and kill them, and you're going to have to fill out a bunch of health and safety forms. Either that, or you can just ignore me, as you probably are doing, okay, and just use rounded figures because the exam is going to care. Alright, so anyway, that's the vertical component of A to C. And we want to know also the vertical component of B to C. Now obviously this is going to be a lot easier. Okay, vertical component of B to C, well obviously it's 6 newtons. We've got the angle, we want the opposite, okay, so it's a similar thing. So it's 6 newtons times the sine of 50, not 30, remember. Okay, so if you work that out, oh look, I've got a spare calculator. I'll just use this spare calculator. Oh god, holding 2 calculators at the same time. Right, so it's 6 times the sine of 50. And that comes to 4.60 newtons. Okay, so remember we said the weight, or the this here, okay, is equal to the vertical component of AC plus the vertical component of BC. So in other words, 2.3 newtons plus 4.6 newtons, okay, which obviously gets you, obviously, as he says, putting it into his calculator, 6.9 newtons. So therefore the weight is equal to 6.9 newtons, which obviously comes from your 2.3 newtons plus your 4.6 newtons. Okay? So hopefully you get how that is. Right, so that's the end of question 1, okay? Quite a nice, well, you either spot that or you didn't. If you didn't spot it, the fact that these have horizontal and vertical components, okay, you probably wouldn't have done anything at all on that question, but hopefully you did spot that, okay? But as I say, it's quite a nasty one, really, and there's no nice questions. Apart from the first question, which is obviously name, but you don't get any marks for that, unfortunately, which kind of means I'm going to get 0 in the exam. But anyway, thanks for watching, and we'll see you in the next question.